Good afternoon. My name is Terri Gatten. When was the last time you saw a volcano explode? When was the last time you created a tornado? And when was the last time you saw Coke actually explode? Today I am going to show you fun, easy, educational, and hands-on science projects that even adults can enjoy too. But first I'd like to explain a little bit about STEM. The STEM acronym stands for Science, Technology, Engineering, and Mathematics. This is an exciting and very important approach to education that will prepare kids to be innovators and critical thinkers and help them to engage and explore while helping them also to make connections between school, community, work, and global issues. And I think it will help them to have the capacity to change the world. So I am going to focus on the science part of STEM today by demonstrating simple and exciting science experiments that will align to the STEM objectives. First, I'm going to become a mad scientist. There we go. Because when we do science experiments, we're all scientists, right? Okay. There we go. And it's always important to wear safety goggles when doing science experiments. And there we go. We'll do one last thing. All right, we're ready to go. My first experiment is going to be about gravity. There we go. I'm going to need a chair, and I'm definitely going to need this. Okay, plastic garbage bag. I am going to place a raw egg in my left hand and a rubber chicken in my right hand. I'm going to stand on this chair. Now this experiment works best with the ladder because the higher up you are, the better it is. But since I'm in my kitchen, this is about as high up as I can go. And I'm going to lift these objects up as high as I can, and I'm going to drop them both at the exact same time, and we are going to see which object will hit the floor first. If you think the raw egg will land on the ground first, raise your hand. If you think the rubber chicken will land on the floor first, raise your hand. Okay. We have one for the rubber chicken. Okay. So I need your help. I need you to say ready, set, go, and I will drop both of these objects at the exact same time. Ready, set, go. Oh, woo! Wow, did you see what happened? Both objects landed on the ground at the exact same time. Amazing. How did that happen? Well, it was because of gravity. Gravity's attraction was the same for both of the objects because of Newton's law of acceleration, which made both objects speed up and slow down at the exact same time, and because of the factors of force or weight and, mass or weight and force or pull. The greater the mass or weight of an object, the lesser the force or pull, and the smaller the weight or mass of an object, the greater the force or pull. So the ratio of mass and force was the same for both objects, and they landed on the ground at the same time. Amazing! All right, now we're going to go next to the 3 states of matter. We are going to begin with the ice cube. The ice cube is solid water. This is a solid. You can see the atoms that make up an object are firmly pressed together. They don't move. They don't change their shape. They stay the same. Now, if we hold this ice cube for a while or put it in a glass or a bowl, it is going to eventually turn into liquid water. Now, the atoms in a liquid, they do not have as much energy, and the force is a weaker force, and they're not as close together, and they kind of move around. They still have mass and volume, but there is no shape to liquid. So liquid takes the shape of the container you pour it in. And then we have our last state of matter, and that is gas. That's when the atoms are really far apart. There's lots and lots of energy, and there is no force at all, and there's no shape, no mass, no volume, and they're kind of like all over the place. And that's what gas is, okay? So we have our solid, we have our liquid, and if we pour the liquid into a kettle or a pot, we have, you see that steam coming up? We have our gas. And here we go. And here it is. Okay, now, if I let this water in this kettle cool off, the atoms that were going really crazy are going to start to come closer and closer together. And there's going to be less energy and more force, and it's going to become liquid again. And if we pour this liquid, let's say into an ice cube tray, and put it in the freezer, eventually it will become a solid where all the atoms are firmly pressed together and they don't move. So there they are, 3 states of matter: solid, liquid, and gas. And now we're going to talk about air pressure. See this bottle here? The air pressure is the same outside the bottle as it is inside the bottle. And I have a hard-boiled egg. Well, that hard-boiled egg does not fit in my bottle. And there's no way I can get it to fit inside the bottle unless I slice it up, which I'm not going to do. So let's try something. Let's try this experiment. This is really cool. We're going to light the end of this strip of paper and put it in the bottle. And we're going to put the egg on top like this. Okay, now let's see what happens to the air pressure. Do you see what's happening already? It is beginning to fill up with smoke. It's heating up the inside of our bottle. It's actually changing the air pressure inside the bottle. So what's going to be eventually happen is the air pressure is going to escape out of the bottle, and the air pressure is going to become greater on the outside of the bottle than it is on the inside of the bottle. Oh, and I see something already happening with my egg. I already see it. Okay, let's see. It's moving inside the bottle. And why is that happening? Again, it's because of decreased air pressure inside of the bottle because of the heat. All right, so I'm going to keep my egg right over here, and we're going to keep watching it as I do my other experiments and see what happens. Okay. Next, we're going to look at a tornado. We're going to create a tornado. And what I did was I took 2 empty soda bottles. I filled one of them up 2/3 full of water, and I left the other one empty, and I screwed on a tornado top on the top of the water bottle, the bottle with the water, and then screwed the empty one on top at the other end of the tornado tube. Now, tornado tubes are probably about $5 or less, or you can make your own tornado tube by looking online. Okay, we ready? And now we're going to flip it, and we're going to see what happens. We're going to give it a little spin, and we're going to see what happens with our tornado. And keep looking, because we're going to see what happens. There it is. You see it up there on top? And you see the vortex in there? And that is the water is being forced in a circle. That's what a vortex is. And it's creating a tornado right there. And how are tornadoes formed? Well, tornadoes are formed by cool, dry air mixing up with warm, moist air. And then when these two different types of temperatures mix together, the wind speed will increase and cause a rotating, violent column of air when the cloud touches the ground right after a thunderstorm, and this causes a funnel cloud, which is also called a tornado. Okay, so let's try it on this side this time. Here we go. Okay. And there we go. And there is our little tornado right on the top there. Cool. Now tornadoes can be very, very, very destructive. In fact, they can lift up, along their path, they can lift up things as light as dirt or as heavy as a semi-truck. And so this tornado really isn't that realistic, is it? Because it's cleared. A real tornado will have all kinds of objects and dirt and things inside of it. So I think what we need to do, oops, is put something right inside our tornado. Okay, so let's put in a little dirt. Okay. And we can put in maybe some grass. All right. And then I have some little Lego pieces. Let's put in some objects that can represent houses and cars and trucks and trees and all kinds of stuff. Okay. So here we go. All right. Now, let's try this tornado. Okay, screw it on again, flip it. And let's see what happens now with our tornado. Woo! And that's more realistic of a real tornado. There we go. Okay, so we'll let that go over here. Now, our egg still hasn't gone inside. It hasn't. It's about halfway in, isn't it? So, what I'm going to do is I'm going to take, this time, a little bigger strip of paper. And let's see what happens to our egg this time. Okay, here we go. There we go. Now, boom! There we go. There we go. So as you can see, we just needed to have a little bit more heat in that bottle, and there you go. The egg went right in. Amazing. Okay. Now we're going to look at our 4 layers of soil. Kids love to do this. They love to make the 4 different layers of soil. I already put it together because of time. And on the top we have the O horizon, which is a little thin soil that has organic matter such as dead plants, bugs, and leaves. Nothing grows in this layer at all. Then we have our topsoil, which is the darker soil here. That's where you will find most plant roots. This is made up of sand, silt, and clay. The more balanced these 3 items are, the better the soil. And then our B horizon, which is our subsoil, has mostly clay and some organic material from the topsoil. You will only find deep plant roots in this soil, such as tree roots. And then our bottom layer is the bedrock, which is C horizon, and is mainly made up of rock and some clay. Okay, so now what we're going to do is we're going to pour some water in here and see what happens. Okay. All right, so we're going to pour some water, and we're going to see what happens to our water. And it's starting to soak in right here. Okay. Now, our topsoil, already see it has gone right through the top, the O horizon soil, the organic, the very top part of the soil, because there are very large air spaces in this soil. It doesn't hold water at all. And then I see it going down to our topsoil, the A horizon, and the topsoil, it has large and small spaces for air. So it holds some water, but lets some water go. That's why it's perfect for planting your seeds and bulbs. And then, eventually the water will go down to the B horizon, which is our subsoil, and there's very tiny air spaces there. So most of the water will be kept in our clay area, our B horizon. And if any water gets through that, it will go down to our bedrock, where there are really no air spaces at all, maybe very extremely tiny ones, and the water will just stay down here. So what you do is you pour water in, and what you can do is you wait probably for 15 minutes or so, and you'll start to see the water coming down, and then you'll see the water that's left on the bottom layer. Pretty cool, amazing. All right, now we're going to make a volcano erupt right now before your eyes. This is my homemade volcano, made out of borax and cornstarch and water. I let it stay white. I was going to paint it, and I thought, no, I'm going to let it stay this color so we can really see the lava coming out of it, okay? Now, what is a volcano? Well, a volcano is a mountain, but there's something different about it. It's got a tunnel inside, and that tunnel goes all the way down to the Earth's crust, where there's lots of gas and hot molten rock going on down there. And there's also these large stone plates. Now, when these stone plates start to shift, and that causes friction, and the friction causes the gas and the molten rock to explode, come up the tunnel, and come in and out of the volcano. So we're going to demonstrate that right now. I have baking soda, just regular baking soda, inside my volcano right here. And you can make your very own volcano. Just look online. There are tons and tons of different ways to make a volcano. Or you can use a cup and a bowl. It's very easy to do. Okay. So here is my vinegar. I'm going to use vinegar and baking soda to make my volcano erupt. All right. The baking soda is inside the volcano, and here is my vinegar. What I'm going to do with my vinegar is I'm going to add a few cups, ooh, you could if you had a lot, a few drops of food coloring to make it the color of lava. And then I like to add a few drops of dishwashing liquid because lava has bubbles in it from the gas. So I like to use some dishwashing liquid. Mix it up a little bit. Now you ready? Let's watch our volcano erupt. Here we go. And there you have it. Our erupting volcano. Now the acids in the baking soda and the acid in the vinegar reacts and causes lots and lots of bubbles, and all these bubbles cause this gas, which causes the eruption. And you can also do it another way. You can put vinegar already in a cup like this, and you can add your baking soda right to the vinegar. So here we used baking soda inside and then poured in the vinegar. This time we're putting vinegar inside and pouring in the baking soda. Will it have the same reaction? Let's find out. Woo! So what do you think has the bigger reaction? When you put the baking soda in first or the baking soda in last?
Baking soda in last.
Yes, that definitely has a bigger reaction. And there you go, your very own erupting volcano. Okay. All right, and our tornado is finished here. And I wanted to mention before I moved on is with tornadoes, you can take a water bottle, put a few drops of dishwashing liquid in that water bottle, shake it up really good, spin it around, and there you have it, your own little mini tornado. Very, very easy to do and educational and fun as well. Okay, now our last set of experiments are Halloween themed experiments. Okay, our first one is a creepy lava lamp. I love this one. Kids love this one. They love to make this and bring it home. All right, now you fill up a soda bottle with a quarter full of water and 3/4 full of oil and leave a little room at the top. Okay. Now, if you mix this up, what will happen? Will the water and oil mix together? They will for just a little bit, but then they will always separate. Oil and water don't mix. It's because the oil is more dense, it's more light, and there's more molecules in the water, and that's why they will never mix together. Okay, now I'm going to use blue food coloring this time. I'm going to put about 10 drops in, okay? You gotta put in enough of this stuff. All right. There we go, cool. Now I'm going to use, makes the magic of the lava lamp, Alka-Seltzer. So kids, your parents need to be the ones that take care of that. Okay. All right, so you break up the Alka-Seltzer and you put it in and watch the magic begin. There you go. Your very own creepy lava lamp. And the great thing about these lava lamps is you can keep them forever. Just put the cap back on, keep some Alka-Seltzer around, and you can do it over and over again. And if you want to put objects in it, theme-based objects, like for Halloween, you can put little eyeballs or spiders in there or anything you want to do. And you can use any kind of color you want as well. Okay, so there you go. I'll put in a little bit more. And we'll put it right over here. This is our lava lamp. Now, how does this happen? Well, Alka-Seltzer has carbon dioxide in it. And the carbon dioxide causes more and more bubbles to form. And when there are enough bubbles, it causes little explosions. And that's how we have this cool stuff happening in our lava lamp. Very cool. I'm going to put one more tablet in so we can have that going for a little bit. Okay, there we go. You can put as much Alka-Seltzer in. Obviously, the more you put in, the cooler the effect of the lamp. Okay. 2 more. This is our ghost slime. Kids love to do this stuff. They love to do it because they can make the whole thing themselves. Okay, which is really cool. All right, you take a bowl. This is really quick. This takes like, I'm going to do it really fast today, but it's really like 3 minutes to make. Okay, you pour in clear Elmer's glue. You can use white Elmer's glue too, but I think the clear works the best. Pour it right in there, and then you're going to pour in, actually, some warm water, which I'm going to take right from here. Perfect. And then you fill up the Elmer's glue with the warm water. And kids, be careful. Let the adults in your household do this for you. Okay. And you pour that in. All right, then you mix that together real quick. There you go. Okay, you can start. Ooh, this is pretty cool. Okay. Now, if you want to add some food coloring, I'm going to add green because I think of Slimer from Ghostbusters. Think of that awful green slime. Okay, there you go. It's going to be really cool. And then in this cup, we have 1/4 cup of warm water and borax, which you can really only buy in a big box. So I probably have this forever. Okay. So the borax is what really does the trick in this. Okay. So here we go. You have to make sure they're mixed really, really well or it doesn't work very well. Okay, here we go. You pour in the mixture of borax and water and mix it in. You can already feel it thickening up. Ooh, there it goes, see? We have green slime. You see how fast and easy that is? There you go. Green slime. That took what? A minute? And kids love to do this with it. Oh, yeah. So, if you used less water and more borax, you'll make Play-Doh. If you use, let's see, more water and less borax, you'll make Gatten. So you can make 3 different kinds of things from borax, water, and glue. So, green slime, really cool. Okay, I have one more experiment. We're gonna watch Coke explode. This is our witch's brew experiment. We have to go outside for this. All right, and take our Diet Coke, and we're gonna take our Mentos, and let's head outside. Okay, I need everybody to stand back. All right, so this experiment, we need Mentos and Diet Coke. You can purchase a geyser tube, which is under $10, or you can stack the Mentos up in your hand and drop them in the Coke as fast as you can. Either way works. All right, this is our witch's brew. You ready? And do not open the Diet Coke until right before you do the experiment. Okay. And I'm gonna run back. Okay, now let's see, what do they say in Macbeth? Double, double, toil and trouble. And there you have your exploding witch's brew. Now, what happened here is the carbon dioxide in the Coke reacted with the coating of the Mentos. The coating of the Mentos has these tiny little craters that collect bubbles, and the more bubbles that were collected,
the more it created gas. And the more gas there was, the more likely there was going to be an explosion. So I hope you all enjoyed the demonstration today. I certainly enjoyed demonstrating all these really cool and fun science experiments for you. And what we need to remember from all this and learn is that science can be fun, and science is very important in the education of children. And we need to encourage and teach the STEM objectives. And we also need to try to make science courses more fun, to capture the attention of kids and plant those seeds of innovation, curiosity, creativity, and interest. So in conclusion, STEM is everywhere. STEM shapes our everyday lives and it impacts our future. And finally, STEM affects what's closest and dearest to us, our children. And so, everybody, please remember that these science experiments are affordable, easy to do. You can find these and many, many more online. You don't have to be a scientist to do them. Kids love to do them, adults have fun, and while you're doing these experiments, you learn about the physical and environmental sciences. Thank you.